Okay. I'm leaving this up here just to say that there is a video that explains how to do this problem using the unit circle. And we can use the unit circle for this problem because of the value inside this tangent. There's a finite list of outputs from tangent that we can use the unit circle for. So that video explains how to use the unit circle. But what I would also like to do is I would also like to do this problem using right triangle trigonometry, because we can, okay, use right triangle trig even when we recognize this, because there's going to be problems where we can't use unit circle trig. So again, just to review, when we're doing an inverse trigonometric function, the input is either an opposite over adjacent ratio, since this is inverse tangent, right? This is using SOHCAHTOA, okay? Because this is tangent, we're not going to use either of these. We're just going to use this as an opposite over adjacent ratio, okay? And let's stop there. Like, if you want to learn how to do this with the unit circle, watch the other video, okay? We're just going to take this approach. Now, if you look at this, you're like, but this isn't a fraction. Okay, now it is. All right, so when we take a right triangle approach to this, understand that the output of this, what I'm going to put in this place, is an angle, right? What that angle is, we're still yet to find out. And then what I'm going to do is I'm going to take the cosine of that angle and get an output for that. So if I choose to do this with a right triangle, okay, and I'm just going to draw it like this. It's not going to be perfect, okay? Then the measurements aren't going to be drawn to scale. But what we're saying is there is an angle in a right triangle. And if you take the tangent of that angle, you get negative radical 3 over 1, okay? So if it's negative radical 3 over 1, that's the opposite side of the angle over the adjacent side. The opposite side here, we can label this as negative radical 3. Now, granted, when we do this, okay, and we get negative radical 3 over 1, we're not going to normally label a side as negative radical 3, okay? But for the sake of this problem, we can. So understand that this angle right here, that's the angle that I'm going to take the cosine of. So the final answer to this composite is what we get when we take the cosine of this angle. We don't have to figure out what that angle is right now, because the final answer is whatever the cosine of that is. And cosine is the adjacent side over the hypotenuse, right? So the final answer will be 1 over whatever we get here. And how do we find that hypotenuse? Well, this is a right triangle, so we can use the Pythagorean theorem. We can take negative radical 3 and square it. We can take 1 and square it and set that equal to h squared. When we square a negative number, it becomes positive. When we square a radical, it goes away. So we have 3 plus 1 squared, which is 1, is equal to h squared. So we get 4 is equal to h squared, and h is therefore equal to 2. So this value is 2. So again, how do we take the cosine of this angle? By taking the adjacent side over the hypotenuse, which is 1/2, okay? And if you go back, I don't know, it won't let me. If you go back and look at the answer that we got in the previous video, we did get 1/2 for that. Now, we took a different approach. We took the unit circle approach and used the coordinates that were on the unit circle, okay? But we get the exact same answer. And this just proves that you can use right triangle trig, or in some instances, the unit circle, to come to this conclusion. What I really think it comes down to is understanding what the input is, understanding that it can be an opposite over adjacent ratio, or in some cases, coordinates from the unit circle. The output is an angle. And then when you take the cosine of that angle, you don't really even need to know what it is. You just need to know what the ratio of the sides is, okay, when you do it this way. So 2 ways to do the exact same problem. Right, we have that freedom. We're going to see another video coming up here in a second where we don't have that freedom anymore. You'll see what that looks like.